Good morning. Sorry I'm out sick today. What I wanted to talk about today, our last topic for this unit, Module 5, are similar triangles and how I'm going to prove them similar. Instead of having to say every single side is proportional and every single angle is proportional, I can do some shortcuts, kind of like we did with congruent triangles. So let's take a look at what do we know about congruent versus similar. So first and foremost, the symbol, right? Congruent has the equal sign and the squiggly on top, and similar is just the squiggly. So by definition, how are they different? When I have a congruent triangle, I have not only congruent angles, but I also have congruent sides. However, when I'm talking about similar triangles, I still have congruent angles, but instead of having congruent sides, I now have proportional sides. And so another way you can think about that is they're growing and shrinking by the same amount. So that proportional is where we set up two ratios. A ratio like A over B is equal to C over D, something like that. And I would recommend writing all this stuff down in your page right now. I think it's 53. So by definition, similar triangles are where we're talking about these proportional. We're talking about a dilation. So let's talk about scale factors. So specifically on congruent triangles, the scale factor is just going to be 1 because anytime I multiply something by 1, I'm going to get the same thing. What changes is when we talk about similar triangles, we've got an enlargement where I've got my scale factor greater than 1. For example, something like 2, 3, 10, right? Wow, I can't write with this pen very well. 10, etc. And a reduction, that's going to be something like 1/2, 1/5, things like that. So how can I prove congruent triangles? I don't know if you remember doing this, but this is when we talked about proof. So this is where we talked about things like side, 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 where I showed all the sides were the same, or I had side, angle, side, where that angle was right in the middle. Angle, side, angle, where the side was between the two angles. Angle, angle, side, where the side was just somewhere else. And then hypotenuse leg was when I had that 90-degree angle. But when we're talking about similar triangles, well, we only have 3. So I've only got 1, 2, 3. Yay, I've only got 3 things I need to prove. So this is going to be side, side, side similarity, side, angle, side similarity, and angle, angle similarity. So side, side, side is a preview. All 3 sides have to be proportional. If I have that, then I'm done. They're similar. I don't need to know anything about the angles. However, side, angle, side means I've got 2 sides that are proportional, and then that included, the one in between angle, is congruent. Or if I can prove that all the angles are congruent, then I'm done. They have to be similar. I don't have to know anything about the sides. So let's look at an example really quickly. So my example for congruent was showing you that I've got all sides are congruent, right? 3 is equal to 3, 5 is equal to 5, 4 is equal to 4. Cool. Now similar is a little bit different. I've got 3 is to 9, so I've got 3 going to 9. And what do? Hopefully you recognize here that I've just multiplied by 3. So do I have the scale factor here? Well, how do I get from 5 to 15? Well, again, I've got times 3. And then you notice 4 to 12 gives me the same thing, times 3. So this would actually prove side, side, side similarity because all the sides are proportional. They have the same scale factor. They grow by the same amount. So let's take a look at this first one. When we're talking about similarity, the first, oh, my little thing went away. Now you're looking at everything all at one time. The first thing I can do here is talk about angle, angle. This is the easiest one. Angle, angle similarity. So what that means is I have to have at least 2 of my angles to be congruent. Now, if you noticed in your picture originally, these numbers weren't in there, this 80 and this 40. What I've done here is I've solved for this angle. Well, how did I do that? Well, I said 60 plus 40 minus 180 because I have a triangle to get this angle. And then I did the same thing here. Well, what's 80 plus 60? Subtracted that from 180 and I got 40. So now what I can see here is that all I needed were 2 of these angles. So now I've got an 80 and an 80, and a 40 and a 40, and then coincidentally the only thing left over could be 60 and a 60. So that's why I can prove that these triangles are similar by angle-angle similarity. So I only need two. Now in this situation I give you all three to show you, but I only need two. I could have all three, but I only need two. So what can I say about this? Triangle MNO is similar to triangle QPR. So let's take a look at another one. I don't need to know anything about the sides. I don't care if this is 3 and this is whatever. I don't need to know that. These are similar just because the angles are congruent. So let's take a look at our next one. Side, side, side similarity. So kind of like I already told you before, what I need to show are that all sides are proportional. They're all growing and shrinking by the same amount. So let's take a look at our example here. Let me see if I can do some fancy maneuvering with this. Kinda. So what I notice here is that I've got triangles. So what I'm going to do is I'm going to set up my extended proportion. I'm going to say this pink side is to this pink side, as this green side is to this green side, and this orange side is to this orange side. I notice that this triangle has just been turned onto its side. So what I can say is that this line AB is corresponding to FD. They're in the same location, so I'm going to create my ratio and do the same thing. This green side BC is corresponding to EF, and AC is corresponding to ED. When I do this, if all of these equal the same thing, then I can prove they're similar by side, side, side. So let's look. I've got 5 over 4, 12 over 9.6, 13 over 10.4. I just plugged all my numbers in. Well, I have no idea what this means. Well, let's look. When I type this into my calculator, I get 1.25 for every single one. So these two triangles are similar by side, side, side. I know nothing about their angles, and I don't need to, because they're similar just showing these sides are proportional. So now I can make a similarity statement by saying, whoops, that was ugly. Triangle ABC is similar to DFE. Now notice the order I put this: A, B to C, D, F to E. So let's take a look at our next one. And our last one, truthfully, let's talk about side, angle, side. So this is kind of a mixture of both. I need two sides to be proportional like this, and then I need just one angle to equal another. So let's take a look at our picture. Well, let's look at the words here. So I know that I need two sides that are proportional and the included angle, so the one in between. So let's take a look. I've got an angle here and an angle here. So just like we talked about earlier, notice this side GH and HI, these are my two similar sides. The angle is in between them, and LK and KJ, K is the angle between them. Both these angles are congruent, so my included angle is congruent. Now let's see if the sides are proportional. So should GH, or does GH, is corresponding to LK, HI is corresponding to JK. So let's see, are these proportional by plugging them in? Well, what's 5 over 7.5? 7 over 10.5? Yeah, I get 0.67, 0.67. So without knowing anything about this side GH, I know nothing about it, or this side JL, or any of the other angles. I don't need it. All I needed was to say side, angle, side, and yeah, these are similar. However, if this was 7.6 and then I didn't get the same decimal, then this would have been no, not congruent. So remember, that's always a possibility here. So as we look at these next ones, I want you to keep that possibility in mind. So when I look at this first one on our practice, I'm kind of giving you all the spoiler alerts here. So when I look at this one right here, I call this 1. This looks like side, angle, side, right? But I don't know that for sure. It looks like it, but I don't know for sure. I can't say angle R is congruent to angle K. So from side, angle, side, whoops, pencil's going crazy, angle, side, I've got the angle part done. Yep, that's true. So let's talk about the sides. Is RS proportional to KL, and TR are proportional to MK. Well, when I plug in my numbers, 6 over 30 or 11 over 55, yeah, I get the same thing. Therefore, I can make a statement saying this triangle is similar to this triangle by side angle side. So when I look at the next one, what does this look like? Side angle side, side side side, or angle angle angle. Well, I notice right now, this pen is hard to write on with my computer, that I don't have any angles. So the only way I could prove this would be by proving side, side, side. So let's see if I can set up my extended proportion. They look similar, but I don't know for sure. So when I plug this in, ML should be corresponding to PQ, NL should be corresponding to PO, and ML should be corresponding to OQ. When I plug my numbers in, yeah, 2 is equal to 2 is equal to 2. So these two triangles are similar by side, side, side. I don't need to know anything about the angles. That's enough. So I want you to try these next two on your own. Can you prove these are similar? So pause the video, see if you can. All right, as I go through these last two, hopefully you notice this one, I don't have enough information. I've got a side is congruent to another side. Remember, this tick mark means congruent, and then an angle, but that's not enough information on either one, so not similar. There's not enough information to prove that. Now on number 4, this was a little bit tricky. I don't have any numbers here, but what I do have are these little arcs. So this tells me angle B is congruent to angle L. And I also know because these angles are what? Yes, you guessed it, vertical. I don't know if I can spell that with my computer writing. This is an adventure. Vertical, angle K is congruent to angle K. Therefore, that's all I need. I know that these have to be similar triangles by angle-angle similarity. So what I want you to do now is you now have a new sheet that I want you to turn in. So there are 10 problems on it. I'm actually going to ask you to pause this video where you can watch this second video here in a minute when you finish. But I'm going to give you the answers to this next one because I want you to be ready for your test tomorrow. Your test is still on Tuesday. Okay, so I'm going to pause this video, show another one that will give you the answers to your practice. So work on your practice now.